All right. Okay, guys, we are going to continue to factor, okay? Now, today, this week, the types of expressions that we are going to factor this week are kind of the more typical types that you will generally see, okay? We are going to be factoring a lot of trinomials this week, okay? And with this case here, when I say A is greater than 1, the first term that you see this week, its coefficient, that number in front of the variable, is going to be larger than 1, okay? And without getting into all the reasons why I do it this way, we are actually going to take care of the tougher trinomial first and move into an easier one on Wednesday, okay? So if we can kind of get a good handle on things today, you're going to be in a great place to be able to handle trinomials that come your way as far as the factoring process, okay? So first things first, we need to do a quick review, all right? Because this is going to be very important, okay? Where do these terms come from? As we've started factoring, we've talked about that factoring is putting these expressions back to where they came from. What did we multiply together to get these expressions that we're working with? Okay, that's kind of what factoring does, all right? Now, in the unit that we started with coming back off Christmas, we did a lot of this right here. We did a lot of multiplying, bless you, okay? We did a lot of going forward. So let's go back through this real quick. This is a binomial times a binomial, and here's what we did. We started with 2x. Make sure I've got the right pen here. We started with 2x, and we're going to distribute that 2x. 2x times x, as a matter of fact, I'll do this. We're going to go 2x times x, and then it was 2x times 4, and then we came back and grabbed this 1, and we go 1 times x, and 1 times 4, okay? So I'm really kind of drawing it out here, okay? That's what we did. All this is a double distribution. It's a binomial times a binomial. We did a lot of multiplying, okay? 2x, what is 2x times x? 2x squared, that's right, because we're able to add those exponents because we're multiplying, okay? 2x times x is 2x squared. What is 2x times 4? 8x. What's 1 times x? 1x. And what was 1 times 4? 4. So we did all this distribution. We got all these terms laid out here. These were the 4 terms that we got. 2x squared plus 8x plus x plus 4. And then we also had a couple of terms that you were able to combine because they were considered like, right? So 2x squared. What's 8x plus 1x there in the middle? How many x's would that be? 8x plus 1x. If I have 8 x's and I add 1 more x, how many x's do I have? I have 8 x's. I have 8 apples. I add 1 more apple. How many apples do I have? I have 9 apples. So if I have 8 x's and I add 1 more x, I still have just 9 x's. Just because you add apples doesn't mean you get oranges. So if I add x's, I don't get x squareds, right? 8x and 1x is 9x, and then we have plus 4. So this is what we ended up with. 2x squared plus 9x plus 4, okay? Now, what's going to be very important about today is trying to draw an understanding of where this stuff came from. You see this 2x squared right here? Where did that come from? 2x times x. That's the first 2 things in the parentheses there. That 2x squared is a result of the very first two things in those parentheses, 2x and the x. Okay? Where did this 4 come from? What gave us the 4? The 1 times 4, the last two things in the parentheses. So the first two things in the parentheses give us the first term. The last term is made up of the last two things in the parentheses multiplied together. Okay? Now you see this term right here? The one that I just boxed in blue? That's the problem. This is the term that becomes the problem when factoring. Okay? Where did 9x come from? Look at what 9x came from. 9x was a combination of a couple of terms. It was a combination of those two products, 2x times 4 and 1x. That middle term, and that's what we're going to kind of discover through today's investigation and factoring, is that middle term is what causes us the issues, because it is produced by a combination of terms. Okay? Now, hopefully I can teach you some keys to look for that will help you find the numbers quicker to give you this middle term. Okay? But that's what we've got to do today. Okay? Where do these terms come from? The first term, guys, we're going to get the first term. And you're going to get the last term. The first term's the first two things. The last term's the last two things. Guys, it's this middle term is where we're going to spend our time trying to figure things out. Okay? But that's where it comes from. All right? We did a lot of that going forward. Now we've got to go backwards. All right? Everybody good here? Everybody good? Everybody got what they need off this slide here? We good? Okay. All right. Now, when I do factoring, when I do factoring trinomials, these are my 3 keys. Okay? You will hear me say this quite a bit. The 3 keys for me are the first term, the last term, and the last sign. First term, last sign. And you'll see me do this quite a bit. First term, last sign. I tend to circle those things. The first term, the last term, and the last sign. Those are my 3 keys. That's what we need to look at. Those tell us quite a bit. Okay? Now, what is it about the last sign? Okay? This last sign right here. That last sign is going to tell you if you have to add or subtract to get that middle term. Okay? That last sign is going to tell you if you have to add or subtract to get the middle term. And as I mentioned on the previous screen, guys, that middle term is typically what causes us the issues. Okay? So it's kind of nice to know, do I have to add to get that middle term, or do I need to subtract terms to get that middle term? That is going to help. That's why it's a key. First term, last sign. Okay? Those are my 3 keys. Okay. So let's do one. All right? First example, 2x squared plus 5x plus 2. We still want to look for a greatest common factor. We're always going to look for that first. And I will take the suspense out of it for these first couple here. There is no GCF right here. 2x squared plus 5x plus 2. There is no greatest common factor, but we still want to look for that, okay? But there is no GCF, so I'm going to go first term, last sign, and we're going to get a couple sets of parentheses. Now, take a look at this first term, 2x squared, okay? And we mentioned on that very first screen, the first two things in the parentheses are going to multiply together to give you the first term. What's the only way to multiply and get 2x squared? 1 times 2. So we're going to go 2x times 1x. You can go 1x times 2x if you want. I'm going to go 2x and 1x. Guys, the only way, 2 is a prime number. The only way to multiply and get 2 using integer numbers is 2 times 1. So I'm going 2x times 1x. Okay? Look at this last number. It's a 2. We know that the last two things in the parentheses are going to give us the last number. What's the only way to multiply and get 2? 1 times 2. Okay, so watch this. We're going to go 1 times 2. Okay, what's the last sign? The last sign is a plus sign. Here's what that means. Since that last sign is a plus sign, that means that the outside product, this is what we call the outside product and the inside product has to add to give me 5. Okay? Now look at this. The outside product. What's 2 times 2? 4. Technically 4x. The inside product. What's 1 times x? 1x. Do 4x and 1x add to 5x? It does, doesn't it? 4x and 1x does add to 5x, so that means I've got the right combination of numbers here. Okay? It's the combination of that outside product and inside product that gives me that middle term. Okay? Now, if I'm adding to get a positive number, all these signs are going to be positive. By rule, if you're going to add integers, they have to have the same sign. So if we're trying to add to get a positive 5, both signs have to be positive. That would be a positive 4x and a positive 1x. We are fully factored. 2x plus 1, x plus 2. And like I mentioned, guys, you're going to find 2 numbers that will give you the first term. You are going to find 2 numbers that will give you the last term. The trick is going to be, can you find a combination of those numbers such that the outside product and the inside product will combine to give you the middle term? That's the key. That's where the difficulty typically lies. Okay? Any questions there on the first one? All right, let's go to the second one. Second one, 2x squared plus 3x minus 9. Always checking for a greatest common factor first. A 2, 3, and a 9. Nope. X not common in every one of them. There is no GCF here. So we're going to go first term, last sign. There's my 3 keys. First term, last sign, 2 sets of parentheses. Two x squared. What's the only way we're going to get 2x squared? 2x, 1x. Pencil it in. I mean, that's the only way you're going to multiply and get 2x squared or 2x and 1x using integer numbers. Okay? Now, 9. How many ways can you multiply and get 9? How can I multiply and get 9? 3 times 3 and 1 times 9, right? Okay? So, like, here's the deal. 3 times 3 is 9, right? 1 times 9 is 9. All right? So, I'll tell you what. Let's put in a 1 and a 9. I want you to see something. Okay? 2x times x is 2x squared. 1 times 9 is 9. I told you, I said, look, you're going to get the front end. You're going to get the back end, okay? What's your last sign? Minus, okay? That minus sign is telling you that the outside and the inside products have to subtract to give you a 3. Okay? So, outside here, guys, what's 9 times 2? 18. What's 1 times 1 in the middle? 1. Do 18 and 1 subtract to give you a 3? They don't. Okay? That means this combination doesn't work. So what you'd have to do is you're going to grab an eraser. We're going to try something different. Now, if you wanted to, we could go 9 and 1. Instead of going 1 and 9, we could try 9 and 1. Now take a look here. What's your outside product here? What does 2 times 1 give us? 2. And inside, 9 times 1? 9. Do 9 and 2 subtract to give you 3? No. They don't. Guys, 9 and 1 or 1 and 9, 9 and 1 is not going to work. So you say, you know what? 1 and 9 is out. Okay? So, we're going to put 3 and 3 in there. 3 times 3 is still 9. The front end gives me 2x squared. The back end still gives me 9. But now let's look at this combination here. What does the outside give me? 2 times 3? 6. Inside, 3 times 1? 3. Do 6 and 3 subtract to 3? They do. Okay? This combination is going to work. Okay? Now we just got to get the signs right. What kind of a 3 is that in the middle? It's positive. Okay? Now remember, with subtraction of integers, you have different signs. Okay? Here's your two options. 6 minus 3 or negative 6 plus 3. Which one of those renders a positive 3? 6 minus 3 or negative 6 plus 3? 6 minus 3. This one right here. So my 6 needs to be positive, my 3 needs to be negative. So look at this. We're going to go minus plus on my signs. That should give me a negative 3 in the middle. That gives me a positive 6 on the outside. 6 minus 3 is positive 3. Guys, there's going to be there could be some trial and error with this, okay? But again, that's why you need that, bless you. That's why you need an understanding of where these terms come from. What's generating these terms? If I know where these terms come from, I can go in there, I can manipulate numbers, I can manipulate signs to get hopefully what I need. But we've got to know where this stuff comes from. You're going to get the front end, you're going to get the back end. It's going to be a matter of the right combination to get the middle, to get that middle term. Okay? Now, I would say this, okay? When you are faced, kind of like with 9 right here, when you are faced with options, like for 9, we had an option of 3 and 3 or 1 and 9, I would recommend that you always start with the factors that are closer together. So really, I would probably start with 3 and 3, but I wanted to kind of show you kind of what happens, okay? So if you encounter a number that has multiple ways to multiply and get it, and you've got these number combinations, I would usually start with the combination where the factors are closest together. Okay? Let's do another one. There we go. 3x squared minus 2x minus 5. Trinomial. Is there a GCF? Is there a GCF other than 1? Is there anything common besides a 1? I don't think so. 3, 2, and 5. There's no x's in every one. So again, we're going to go our 3 keys here. We're going to go first term, last sign. First term, last sign. 2 sets of parentheses. What do you think about 3x squared? What's the only way we're going to multiply and get 3x squared? 3 times. Yep. 3x and 1x. Guys, if you've got a prime number on the front and or back end or both, this is pretty good. You have limited choices here, okay? 3x and 1x is 3x squared. Now, 5. 5 on the back end. How many ways can you multiply and get 5? One way. 1 times 5, right? So here's the dilemma. Are we going to go 1 and 5 or 5 and 1? What's our last sign? It's subtraction. That means that the outside and the inside together have to subtract to give me a 2. And somebody said, what do you want to go, 5 and 1? So if we go 5 and 1, what does the outside give me? That gives me 3. What does the inside give me? 5. Do 5 and 3 subtract to 2? Does. Nice. So this combination works. Now, we got to get the signs. What kind of a 2 is it? It's negative. So, remember, guys, subtraction of integers, by rule, the signs have to be different. So here's your 2 options. Negative 5 plus 3 or 5 minus 3. Which one of those renders a negative 2? That one right there. So I need that 5 to be negative, which means I probably need to go minus, plus. Negative 5 on the inside, positive 3 on the outside. Got what I need. Guys, and again, remember, this is just distribution. You have a way to check it before you move on to the next one. So we really shouldn't be leaving it going, gosh, I hope I'm right. I mean, you can check it real quick. At least you can check your outside, inside. Because that's the part that's going to get us. You're going to get the front end. You're going to get the back end. Are we going to get the middle? Okay? All right, questions there? We good? All right, next one. 3x squared minus 8x plus 4. 3x squared minus 8x plus 4. This combination of signs that we're getting ready to deal with right here, this is one of the most missed. And I'll get to the reason why here in just a second. Okay? Is there a GCF better than 1 here? Nope. 3, 8, and 4. X is not common at all. Here we go. First term, last sign. 2 sets of parentheses. Hopefully you're starting to see the routine a little bit here. First term, last sign. How are we going to get 3x squared? Three x, 1x. Front end's easy. Now, 4. How many ways can you multiply and get 4? What are they? There we go. Okay, so again, here we have a number. We have a number that has options, right? 4, we can go 2 times 2 or 1 times 4. And as I mentioned, strategy-wise, if I have options, I would probably start with the 2 and the 2. I would start with the factors that are closer together. So I'm going to choose 2 and 2 for my starting point, okay? What's my last sign? What's the last sign? It's addition. That last sign tells us that the outside and the inside have to add to 8. What does the outside give me? 3 times 2 6. Good. And on the inside, 2 times 1, 2. Do 6 and 2 add to 8? They do. So this combination is going to work, okay? Why is this one of the most missed sign combinations? Well, here's why. Last sign's plus. That means we're adding integers. By rule, addition of integers requires same sign, identical signs. But what students see here is you see a negative and a positive, so I think there's a thought there going, ooh, I see one of each sign, I bet I need one of each in these parentheses. Guys, if you're going to add integers, you have to have the same sign. And if you're going to add 2 integers to get a negative, both signs would have to be negative. Both those that needs to be minus minus. Happens all the time. And I really think it is because students see one of each. You tend to have a thought that, hey, I need one of each of these parentheses. Guys, pay attention to that last sign. If that last sign is a plus, both of your signs are going to be the same. They're either going to be 2 positives or 2 negatives, depending on that middle term. If the last sign is a minus sign, then you're going to have one of each, and you got to kind of figure out which one's which. Okay? But we're just following integer rules here. Okay? But that is one of the most missed sign combinations for that reason. Last sign's a plus, both signs are going to be the same. Guaranteed. Okay? All right, so far so good? Okay. Here we go. 5x squared plus 19x plus 12. Numbers are getting a little bit larger now. Okay? Is there a greatest common factor better than a 1? I do not believe so. I believe you are correct. So we're going to go first term, last sign, 2 sets of parentheses. Look at my 3 keys. What do you guys think about 5x squared? How many ways can I multiply and get 5?
5x. It's x.
I agree. 5x and 1x. Guys, 5's a prime number. You got a prime number on the front or back end, it's a lock. Okay? Now, what about 12? How many ways can you multiply and get 12? What are they? 3 and 4, 1 and 12, 2 and 6. Got options here. And like I said, guys, you can put 3 and 4 in there. It's going to give us 12. We can put 1 and 12 in there. It's giving us 12. We can put 2 and 6 in there. It's giving us 12. Okay? But the key here, is that you're understanding that the outside and inside, what's the last sign here? Plus. The outside and the inside has to add to give us a 19. And again, if we're not sure what to use, I'm probably going to start with 3 and 4. I would start with the factors that are closest together. And the reason I tell you that, it just seems like over years and experience with these things, it tends to be those are the ones that typically work, okay? But sometimes they don't, but that's always a good starting place. What does the outside give us? 5 times 4. 20. And 3 times 1? Do 20 and 3 add to 19? No. So let's switch them. Let's go 4 and 3. If 3 and 4 don't work, let's go 4 and 3. Let's try that combination, and that way we'll see if we'll eliminate 4 and 3. What does the outside give me now? 15. Inside? 4. Do 15 and 4 add to 19? Well, look at there. This is going to work. That's the combination we need. And what kind of a 19 is it? Positive. So we're adding to get a positive result. Guys, this is the easy one. If all you're seeing is plus signs, that's easy. Everything's positive. That's the easy one. 5x plus 4, x plus 3. Factored. If you write it x plus 3 and then 5x plus 4, still good. Okay? It's what's inside the parentheses is what's important, not necessarily the order of the parentheses. It's what's inside of them. Okay? We didn't have to mess with the 1 and the 12. We didn't have to mess with the 2 and the 6, which is nice. Okay? All right, next one. 15x squared minus 27x minus 6. Is there a GCF here? 3. Good. There's a greatest common factor here, guys. If you start noticing that you've got some numbers that are starting to get a little bit elevated, I mean, we should be checking anyway, but especially if you kind of go, gosh, 15, 27, 6, numbers are getting a little bit larger, okay? Check for a GCF. Guys, there is a greatest common factor of 3 here. We need to go ahead and take it. So I'm going to put a 3 out front. I'm going to pull a greatest common factor of 3. If we divide everything by 3, what have we got? What do we get? 5x squared minus, what's 27 divided by 3? 9x minus 2. Now we need to work with this trinomial. What's going to happen if I don't pull this greatest common factor right now? Well, a couple things. One, you're going to be dealing with a lot more options on the front and back end, so it's going to be kind of more of a pain in your butt a little bit to get it factored. Once you get it factored, you're going to end up with some sets of parentheses that have a GCF that you're going to be required to pull out. And just because of lack of experience at your age with these things, most students don't catch that. So I'm trying to help. I want you to catch it on the front end, okay? I always want you to check for GCF first. Let's get the 3 out of there. Now, let's look at first term, last sign. And by the way, that GCF of 3 now has to stay with you the rest of the way. That 3 is part of your answer. We're not going to touch it again, but it needs to be shown. Okay? It's part of the problem. So the 3 is going to stay there. We've got 2 sets of parentheses. First term, last sign. Now we're dealing with smaller numbers. How are we going to break up 5x squared?
5x.
Yep. What's the only way to multiply and get a 2? 2 times 1. Now, here's the only question. Are we going to go 1 and 2 or 2 and 1? That's going to be the only question here. My last sign is a minus sign. So I have to subtract outside, inside to get a 9. So do you want to go 1, 2 or 2, 1? Want to go 1, 2? Let's go 1, 2. What does the outside give me? 10. Inside? 1. Do 10 and 1 subtract to 9? Yes. So this will be the right combination. What kind of a 9 is it? Negative. So that means the 10 would need to be negative. Negative 10 plus 1 is negative 9. So to make 10 negative, does the 2 or the 1 get the minus sign? Yep. Right there. And check it real quick before you leave it. Negative 10, positive 1 is negative 9. That's a quick, really should be a quick mental check. This whole thing right here is fully factored now, including showing the 3. The greatest common factor that we took out must be shown. If we multiply all that junk back together and then multiply it all by 3, we're going to get that back. And we've got to be able to do that. So if you pull a GCF, the GCF will be part of your answer. Okay? All right. Do one more of those. I want to do one more. Last example. Got a trinomial here. Elevated numbers, 24, 38, 10. What do you think about a GCF here? GCF will never be larger than your smallest number. What's your smallest number up there? Okay, so it can't be bigger than 10. Does 10 go into 38 and 24? 2? There you go, I agree. 2 is going to be it, right? Guys, pull a 2. They're all even numbers, but the GCF is 2. Let's divide everything by 2. So 24 divided by 2 is what? 12. 38 divided by 2 is 19. And 10 divided by 2 is 5. Try to get into a routine of grabbing that GCF first. Get it out of there because it complicates the process if you leave it in there and we're trying to factor and then are we going to catch the GCF later? And normally that doesn't happen. Okay? So now, here we go. First term, last sign. Make sure that you show your greatest common factor in front of your 2 sets of parentheses. Now, let me show you something with this one. First term, 12x squared. Is there more one way to multiply and get 12? There is, isn't there? Take a look at the last term, 5. How many ways can you multiply and get a 5? 5 and 1. So here's what I would do. A little bit of strategy here. That first and last term, the last term is prime. It has very limited options. I am going to put 5 and 1 on the back end and lock it in right now. Guys, that's not changing. 5 and 1, that's the only way we're going to get 5 right there on the back end. So with this one, I'm going to kind of shore up the back end first. Now we're going to go up front, and let's take a look at 12 here. 1 and 12, 2 and 6, 3 and 4. My last sign is a plus, so that means we have to add to get a 19. What do you want to try? 4 and 3? Okay, so let's go 4x and 3x. What do we get on the outside? 4? Inside? Do 4 and 15 add to 19. There you go. And it's all positive. We got all plus signs, makes the signs real easy. Plus, plus.
Would it still work if you did it the original way?
As far as...
The whole lines?
Yeah, when you say original way...
Like the way we were doing it before this problem.
Yeah. Oh, yeah. You talking about if we started dealing with the 12 first, or... Yeah, the only thing about that is you would sit there and go, well, okay, I think I'll try 3 and 4, and then you'll try to, you go 5. Yeah, and it kind of depends on your routine, but again, I'm trying to give you things to where if you recognize that one of the two terms or both are prime numbers, like 5, there's only one option, 1 and 5. So I'm going to lock that in. I'm going to put 5 and 1 back there, or 1 and 5, because it's going to have to be that. And then I'm going to come up front and start dealing with 12, but Yeah, I mean, you could have taken 12 and said, look, I'm going to go 3 and 4, and then you go back there and start dealing with either 5 and 1 or 1 and 5. But look for those prime numbers. If the front or back end or both are prime numbers, those are great places to start. If they're both prime, you're going to have limited options, pretty good deal. Check for your GCF, guys. Check for the GCF first. Always check for that. If it's there, if there's one there, get it out. Okay? Get it out of there. All right, any questions? Okay, all right.